In this last section, we're going to talk about how the planets and stars move in the sky. There are 5 planets that you could go outside and see with your naked eye, not counting the Earth. Right? Mercury, Venus, Mars, Jupiter, and Saturn. It's basically the 5 closest planets to the Sun except for Earth, because we see that one all the time. These planets, if they're going to be visible in your night sky, they'll just rise in the east and set in the west. If you don't know what you're looking for, you can mistake it for a star really easily. It just looks like a bright, Jupiter will look like a bright star, Venus would look like a bright star. So they'll just look like part of the sky. They rise and they set. They don't look like anything that would stand out to you right away. But if you keep track of a planet's position compared to the stars, so you're plotting it compared to the stars, so that's my picture here. There's the background of the stars. And over time, you keep track of, in this case it's Mars's position, it will appear to move. Right? The stars are so far away you can't notice them moving, but Mars is much closer. It's orbiting the Sun, we're orbiting the Sun. And so you see Mars move across the stars. So generally Mars, Jupiter, Saturn, they will appear to move east across the stars. So we started here left on the image and we're moving to the left. I'm sorry, we started right, we're moving left. Right. But for a short amount of time, maybe a week out of a year or a month out of a year, the planet will stop moving east. So right here is right where the planet stops moving east across the stars. And for a week or a month, it will appear to slide westward across the sky, across the stars. And then it starts moving normal again to the east. It'll keep doing that again for roughly a year. So when it's moving backwards, when it's moving west, we call that retrograde motion. Let me show you what causes this retrograde loop. Basically, it's just Earth lapping Mars in its orbit. Earth is closer to the Sun. Earth is going to orbit faster. And so Earth will lap Mars. So here's Earth, here's Mars. Right? This red line is our line of sight. So Earth is looking towards Mars, and Mars looks like it's lining up with Scorpius. As the planets orbit, our line of sight changes and Mars will appear in a different constellation. And so if you're watching the top panel, the view from Earth, Mars is almost always moving eastwards across the stars. Most of this time, Mars is moving eastward across the stars. There went the Sun, so Mars is up to in the daytime when that happens. Earth is catching up now, and right when we lap Mars, our line of sight kind of wiggles a little bit, left and right, and that gives us the retrograde loop. One more time. Here we go. So you could say retrograde motion happens whenever one planet passes another. You're not going to see it on a nightly basis. You're going to have to watch the sky for weeks or months, depending on if you're looking at Mars or if you're looking at Saturn, just because the rates are different. The planets move at different speeds. All right. Stellar parallax. All right. This is going to be the stars are appearing to shift because we're moving. This animation that you're seeing right now is completely fake, completely computer generated, and it's completely exaggerated of what you would see in the night sky. So take a look at this star right here. It's barely moving, right? It's barely shifting. What about this one? Let me see if I can pace it with my cursor. Moving quite a lot. Right? So some stars will appear to shift in the sky more than others. That's stellar parallax. It's caused by Earth's motion around the sun. Earth is moving left and right, back and forth in its orbit. We think we're at rest, so we think the stars are moving. It takes a year for Earth to go around, so stellar parallax takes a year for the star to go through its loop. So this is exaggerated. Right? The actual stellar parallax is so incredibly tiny because the stars are so far away. Here's a different way to look at stellar parallax. Right? We have Earth orbiting the sun, and we have Earth's line of sight to a nearby star. The nearby star is red, so that's this guy over here. The view from Earth is the red star. We're going to look at the red star and watch how it moves compared to these distant stars, which are other colors, not red. So here, play. As Earth orbits the sun, the nearby stars appear to shift. The nearby stars appear to make a loop in the sky. Stellar parallax is proof that the Earth moves. If you can find it, if you can measure it, it's proof that the Earth moves around the sun. We couldn't measure it until we had telescopes because the shift is so tiny. Notice this little parallax angle in here. This angle right here can make a right triangle. I'm going to trace out a right triangle with my cursor. And if you've had geometry, because geometry is awesome, if you know this angle and you know the Earth-Sun distance, which is 1 AU, you can find the distance to the star. So what we use parallax for now is actually to measure the distance to nearby stars. Can you imagine that this red star was further away? If that red star was further away, it wouldn't shift as much along the background stars. So a more distant star has less parallax. A more distant star will shift less. Right? That effect is what lets us find its distance.